All right, welcome back everybody to week 2 of our COVID-19 online learning. If you have not already completed everything from week 1, so the 2 assignments and the quiz, make sure that gets done and turned in. Just a friendly reminder that on the quizzes, you have to not only submit it in the form, but to be able to get full credit and even get points for your quiz, you must take a picture of the paper that you worked on and submit a picture of the paper. Several of you would have lost some points if I did not have that paper to go off of for your quiz. So make sure that you post both because the paper can allow you to get some points back that the quiz would not have allowed you on the form. Okay, so here we go. Week 2, day 1. Okay, we today are going to be graphing radical functions. Okay, these are a little bit different than the functions we have graphed before. Okay, so right here, today we're going to focus on the cube root function. So it says the cube root of x right there, y equals the cube root of x. That is the parent function. Okay, so y equals the cube root of x. This is our parent function. And if we try to graph this the way we normally would graph, so a lot of our graphs from the very first unit we did in Algebra 2, we made our table. And if I wanted to say, hey, let's use -2 for x. But when I go to put this in here, y equals the cube root of -2. Cube root of -2. I don't know what that is off the top of my head. It's not a good number. So guess what? -2 might not be a good number to start with here. Okay, our goal here is I need to cube root a number. Okay, so if I'm trying to cube root a number, a good number that I might want to start with is a perfect cube. What's a perfect cube? Oh, 8. 8's a good perfect cube. Okay, so y equals the cube root of 8. Well, I know that the cube root of positive 8 is 2. We also know, because it's an odd root, that I can have a negative in here, meaning I can find the cube root of -8. Well, the cube root of -8 is -2. Okay, now if I think about it, what are some other good perfect cube numbers? Well, I could keep going past 8, and 27 would be another one, but that's a little bit big. So what if I stop at 1? Well, can I cube root 1? Y equals the cube root of 1. Well, absolutely. The cube root of 1 is 1. Just the same as I could cube root -8, I can also cube root -1. Because the cube root of -1 is -1. Now, something in between -1 and 1 that would be pretty easy to use is 0. Okay? The cube root of 0 is 0. And right here we have our parent function. So when I go to graph this, I'm going to go to -8 for the x and down to -2 for the y. -1 for x, -1 for y. 0, 0, 1, 1, and 8, 2 for the last point. Now this looks kind of funny, but this is the way a cube root graph will look. Kind of, well, maybe. Let me try that again. Okay, so it kind of goes at a curved, and then it has like a straightish kind of area in the middle, and then it goes again. Now, on the ends, they don't just go straight. Okay, so on this right side, it's not just going straight. Although my graph kind of looks like that, that's not what's happening. Okay, this graph will continue to move to the positive infinity for x, but at the same time, it's still going to rise to the positive infinity for y. Okay, so let's talk about real quick domain and range. Domain, well, this one is pretty self-explanatory that, hey, on the left side, what's happening? Oh, hey, it's going to keep moving left forever. It's never going to stop. Okay, so that -infinity. On the right-hand side, we just talked about that, hey, that arrow meant it's going to keep going on. So it's also going to infinity. Remember that in the big ideas, they will say all real numbers for something that is negative infinity to infinity. Okay? Now, the range, I told you here on the positive side for x that yes, as it keeps moving, I'll use blue here, as it keeps moving to the right, that it is going to continue to get higher here for the y values. That means on the positive side of y, it is continuing to infinity. Just the same here, on this left side of the graph, as x is going to continue moving left, well, y's are going to continue going down. So, that means on the right side, that's negative infinity to infinity. Okay? Again, your big idea is math. They will say all real numbers. Now, the next page that I'm about to show you should come as no surprise here. That all of these things still mean the exact same thing. Okay, so I'm going to pause and I'm going to write them in. These mean the same thing that they did for squares, so quadratics, the same thing they did for absolute values. Alright, so all of those right there mean the exact same thing. When a is negative, there is a reflection. When the value of a is greater than 1, there is a vertical stretch. Okay, when a is between 0 and 1, there's a vertical compression by that amount. Horizontal shift here in h, I say the opposite of h for a reason. Okay, adding it means it's going to go left, subtracting means it's going to go right. Okay, this adding the k on the outside for the vertical shift means it's going to do exactly as it says. Adding k will move up, minusing k will move down. So now, basically we're just going to do what we have been doing, but with cube root functions. So right here I have this g of x equals the cube root of x minus 1 plus 4. What we are going to do is we are going to name the transformations. We are going to graph it, and then we are also going to name the domain and the range. So I'm going to pause here and I want you to name the transformations. Because the transformations are no different, I said, hey, that minus 1 means it's going right 1. This plus 4 means, hey, it's going up 4. Now to graph, we want to use that same parent function that we did on page 1 here. So that negative 8, negative 1, 0, 1, 8, because I want to be able to cube root the numbers. And then because our transformations were moving to the right, well, moving to the right on our graph is a positive action. So that's why I'm going to add 1 to my x values. And moving up on the graph is also a positive, which is why I'm going to add 4. Go ahead and pause here and add 1 and add 4. When you add 1 to the x's and add 4 to the y's, that right there is what you should get. Go ahead and put that onto the graph. Now, this has not been stretched, compressed, or reflected, so it should look the same as our parent function, but just translated to the right and up. Alright, there's what that function should look like. Okay, when I talk about domain, I have 2 arrows that are going to opposite sides here for x, so that's pretty simple that that domain is that negative infinity to infinity. Now remember, on this right side of the graph, as it's going to the right, it's going to continue going up. On the left, as it's going left, it's going to continue moving down slowly. Okay, so that is why your range is also that negative infinity to infinity. Alright, here is the next one. We're going to do the same thing. Name the transformations and graph it in domain and range. Alright, there are those transformations. Go ahead and pause this. Because we know how to make our changes to our table, go ahead and pause this. I'm going to make my table here, and I want you to put the transformations in the right spot on your table. Alright, so I have here that we should be subtracting 6 on the x's, and then our y should actually be multiplied by that negative 2. Not added by negative 2, but multiplied by negative 2. Go ahead and do that, and then check your table with mine. Alright, make sure your table graph matches mine. I also went ahead and graphed it. I realized that this negative 14 goes pretty far off a graph, okay? Not very often is that going to happen, but sometimes it will. So I just kind of guesstimated where that negative 14 and 4 would be. Okay, so right here, domain and range. Again, domains, they're going in opposite directions. So I have that negative infinity to infinity. And the range, just like it has been this whole time as it's moving on the right, even though this time it's going down as it's moving right, it will continue to move down. And on the left, as it's moving left, it will continue to move up. That is because of the reflection this time, that my graph is going opposite of what it has been. So that negative infinity to infinity. Okay. Hey, I have one more example. I want you to write it down, pause it, and I want you to do this on your own. And this is the last example for the day. Alright, the only thing that I wanted to mention here is that vertical compression by 1/2 as well as the move up by 3. Remember that the order of that matters. I must multiply by that 1/2 before I add to the 3 on those y values. Okay, and also on your graph you're going to see that it did get vertically compressed, so pushed together more. That's why you see more of a flat line than the actual big curve that we are used to seeing. That was backwards to you all. Sorry. Okay, so that is it for today. Thank you.